Have you ever wondered how your body is able to maintain a specific temperature? For humans, our happy temperature, our set point, is about 37 degrees Celsius or 98.6 degrees Fahrenheit. And our body is dynamically managing our temperature so that we can stay very close to that optimal temperature. Our body needs that temperature for a lot of different reasons, like enzyme activity, but ultimately, we have this set point where our body is most optimal in performance, and that's maintained by different feedback loops. The overall idea of what we're learning today is the idea of homeostasis and how in humans, positive and negative feedback loops help to maintain homeostasis. So the first thing is I'm going to write homeostasis at the top of this page because homeostasis is stasis, and I'll draw it this way on a sort of balance. So homeostasis again is balance. It's our body's set point, equilibrium, however you want to think of this. And there are two kinds of feedback. The first kind of feedback is negative, negative feedback, and the other type is positive. Okay, so negative and positive feedback. I want to be clear and let you know that negative feedback doesn't necessarily mean that negative things are happening to our body, and positive feedback isn't necessarily positive things happening to our body, but they have everything to do with these processes and how they occur and what's actually happening. So we'll jump into the first one, negative feedback. Negative feedback is let's think of it this way, suppressing suppressing a stimulus. And I think of this as suppressing a stimulus because the way that this works. So again, our body temperature, our happy temperature is about 37 degrees Celsius. But what happens if our temperature increases to 38 degrees Celsius? Well, there are a number of pathways in our body, hormone pathways, and that's what we're learning with the endocrine system, hormones that will release and trigger other parts of our body to react. And body temperature is exactly one of those examples. So in the hypothalamus is going to be the main center for a lot, or the main starting point for a lot of different hormones, is going to release a hormone that will trigger the thyroid. And the thyroid will release a hormone called thyroid hormone. Okay, and thyroid hormone does a couple of things. Notably, it manages metabolism. So we could either increase our metabolism, and increasing our metabolism would cause more muscle contractions. It would cause the burning of glucose, and that would cause our temperature to rise. Or we could decrease metabolism, and that would cause a loss of heat. And so in the case where our body temperature has gone up to 38 degrees, what do we think? Is it going to speed up our metabolism or slow down our metabolism? If you guessed that it would slow down the metabolism, that is 100% right. So the thyroid hormone in this case is going to slow metabolism. Also, it will cause us, because we're hot, it'll cause us to sweat. And these two things together are going to decrease our body temperature and will bring us back down to our happy set point. On the other hand, let's say that we decrease, we get a little cold, a little chilly. Same process, the hypothalamus will trigger the thyroid to release thyroid hormone, and instead of slowing down the metabolism, it will do something else. It will speed it up. So we're going to speed up metabolism. The other thing that our body will do when we're cold is we can shiver. So these are very rapid muscle contractions, and that's going to cause this 36 to come back up to 37 degrees Celsius. When the hypothalamus recognizes that we're back at 37 degrees, we're going to be done. We're going to be done shivering or done sweating, and our body is back to its normal state. Okay, so that's an example of negative feedback where our body is going to try to suppress a stimulus. In this case, it was suppressing the stimulus of too cold or suppressing the stimulus of too hot to get us back down to our normal temperature. Positive feedback, on the other hand, is more of an amplifying effect. So, positive feedback, we simply are going to amplify a stimulus. Okay. And the way that I think of amplifying a stimulus, if you've ever, maybe you've had a microphone too close to a speaker before. I know that I have been there. And the closer you get the microphone to the speaker, the more and more feedback is produced. That's the speaker is kind of sending out a little bit of sound waves, and the microphone is picking that up and amplifying it and putting it back to the speaker, which emits the sound louder, and the microphone picks it up, and it starts this loop of this really terrible, loud, ringing sound. Positive feedback in our bodies is a similar process. So let me show you what I mean. So, for an example of positive feedback, the example I want to share is childbirth. And let me explain. So, I'm going to draw a really simple schematic drawing. So, we'll imagine that this is the mother's uterus, and we have our cute little baby, and here he is, and he's a happy baby. And this is a specific pressure receptor. So it's really called a receptor. As the baby grows, it will put pressure on this pressure receptor at the base of the spinal cord. And what that does is it sends an afferent signal up to the, you guessed it, hypothalamus. Okay, to the hypothalamus. And the hypothalamus is going to cause the release of another hormone. Okay, this hormone this time is going to be oxytocin. Okay, oxytocin is a hormone that does a couple of things. A lot of the time we think of it as the social bonding hormone. But in this case, oxytocin actually travels to the uterus and causes contractions. Okay. So as the uterus then contracts, it's going to trigger this pressure receptor again, sending a signal to the hypothalamus to produce oxytocin, which will travel to the uterus, which will cause the uterus to contract, which will put pressure on the the nerve and back up to the hypothalamus. And this process will happen over and over and over again until ultimately the uterus is back down to its normal original size. So of course the baby is delivered and you have a happy new little baby. But those are the two kinds of feedback. So we have positive feedback and negative feedback. Negative feedback is our body's way of trying to suppress a stimulus, whether it's our body is too cold, um, or positive feedback, where our body is amplifying a stimulus in a way to get us back to our set point. So again, here are these kind of things. So homeostasis is the set of balance, equilibrium in two ways that that happens, either through negative feedback where we're suppressing a stimulus, like with body temperature, here's that hormone pathway, or positive feedback where we're amplifying a stimulus, and here's that hormone pathway is more of a cycle. Okay. All right, I hope that was helpful for you in getting some good information about positive and negative feedback. You're now ready to complete the rest of your assignments in Canvas. And if you have any questions, definitely email me, let me know. Best of luck.